Last class we have done characteristics of chemical reaction. So today we will be doing conditions necessary for chemical reactions. So for the chemical reaction to take place, conditions are required. For doing anything, conditions are required. So for a chemical reaction to happen, conditions are required. So number one is close contact. Number one is close contact. A chemical reaction takes place when two or more substances are mixed together. That is, when they directly come into contact with each other. So for a chemical reaction to take place, there should be a close contact. Okay, for example, you can see in this figure, in one container there is kerosene oil, and in that kerosene oil sodium is immersed. That means sodium is kept in kerosene oil. And in the other container, if you can see, there is water, but they are not mixed, they are kept separated. So what happens? No reaction takes place because sodium is not in contact with water. So until and unless you bring the reacting substances, that is the reactants, in close contact, the reaction does not take place. So number one condition required for a chemical reaction to take place is close contact. Whenever you want a chemical reaction to take place, whenever you want to perform a chemical reaction, the experiment on chemical reaction, make sure that the reactants are in close contact. This is the first and the foremost condition required for a chemical reaction. Then you can see here, when sodium metal comes in contact with cold water, an explosive reaction occurs. But again, in the one scenario, whatever we need is there. We need sodium for the reaction between sodium and water. We need sodium as well as water, and both the things are there. But then also they are not in close contact, because of which the reaction is not taking place. But in another case, if you take out sodium from this kerosene oil and put it in the vessel containing water, then explosive reaction occurs. That means the reaction with huge sound, explosion, takes place. So an explosive reaction takes place when sodium and water comes in contact, and it results into sodium hydroxide and hydrogen gas. You can see the reaction. 2Na plus 2H2O undergoes a vigorous reaction with explosion to give sodium hydroxide and hydrogen gas. Then number two condition that we need is attraction in the physical state of the reactants through solution. So what happens is, sometimes we bring the reactants in close contact, but then also the reaction does not take place. The reaction does not take place. So what happens is, generally we take the reactants in solution form if they do not take place in solid form. So in some cases a chemical reaction occurs when substances are mixed in solution form. This brings the reacting molecules in contact with each other at a faster rate. So this is the reason why we bring the reactants, we convert the reactants into solution form. Whatever you need to react, whatever reactants you need, whatever chemical reaction you want to perform, make sure that they are in the solution form. Why? Because in solution form the rate of contact will be faster. That means they mix up very fast. For example, if you bring sodium chloride, that means stable salt, and in the other side if you take solid silver nitrate and mix them thoroughly, okay, in the powder form. First of all, take sodium chloride, then make the powder of it, then bring silver nitrate, which is also solid, and then again powder it, then mix these reactants. You will see nothing will change. You will see no reaction takes place. But again, if you make solution, so if you take solution of sodium chloride, that means if you put sodium chloride in water and dissolve it in one vessel and in another vessel, in another container or another test tube, if you want to do the reaction in very small scale, then you can dissolve the silver nitrate in water, and then you can see two test tubes with two solutions, one sodium chloride solution, one silver nitrate solution, and AQ here means solution is, this is the solution where solvent is water. That means sodium chloride is also mixed in water and silver nitrate is also mixed in water. That's why AQ is there. Then what happens is, both of these are solution, both of these are soluble, you don't see any solid in it, but as soon as you mix, you will start seeing that this one insoluble solid, silver color means white insoluble solid will start settling at the bottom. You can see it, okay, that is silver chloride. So you can see here the downward arrow. This downward arrow represents precipitate. This downward arrow represents precipitate, and this is silver chloride, which is insoluble in water. And then another product you will get is sodium nitrate, which is soluble in water. So here what is the characteristic of the reaction here? Formation of precipitate. So looking at this precipitate, you can make sure that the chemical reaction has taken place. So number one, close contact. Number two, physical state. So generally what we do for a chemical reaction to take place, for our reaction to take place faster, we make solution of the reactants. Then third one is heat energy. So third one is heat energy. Okay, so third one is heat energy. Some of the chemical reaction, they do not take place by simply bringing them in close contact or by converting them into solution. So some of the reactions are there for which we need to heat, for which we need heat. So you can see example out here. When lead nitrate is heated, it breaks down into lead monoxide, nitrogen dioxide and oxygen. So simply here is one reactant only, so no question of bringing them in close contact, because for bringing them into close contact, what we need at least two reactants. Here is only a single reactant. And another thing, if we convert this into solution form also, nothing will happen. So here you don't have to convert it into solution form. Directly you start heating this solid. Then this lead nitrate will convert into lead monoxide, nitrogen dioxide and oxygen gas. So here what characterizes that this is a chemical reaction? Evolution of gas. One of the characteristics of a chemical reaction is evolution of gas, and here you can see oxygen gas and nitrogen dioxide gas will be formed. Then B, If iron powder and sulfur powder are mixed, they do not react. Now, if you bring iron powder and sulfur powder in close contact, then they do not react. If you make solution of it, then also they do not react. But if you take the mixture of iron and sulfur in a test tube and start heating, then what happen is, then they react. They react to form a new substance, that is iron sulfide. You can see the reaction out here. A bowl full of iron powder and sulfur powder. This is simply a mixture because no new substance has been formed. If you bring magnet near it, then all the iron particles will get attracted towards this magnet, towards the magnet. That means no reaction, that means no new substance has been formed. But if you take this mixture in a test tube and heat it, then iron and sulfur react on heating to form a new substance, that is iron sulfide. And in order to make sure that the chemical reaction has taken place, you can bring magnet near this iron sulfide and you will see that iron will not get attracted towards magnet, because now iron has lost its magnetic property, because entirely means a new substance with entirely different properties has been formed now. So 3 conditions: number 1, close contact; number 2, solution form; number 3, heat energy. Then 4th one is light energy. Some of the reactions are there, some of the chemical reactions are there which does not take place by bringing them in close contact, also by converting them into solution form, also by heating them also. So some of the reactions are sensitive towards light only. Some of the reactions are there which takes place in presence of light only. Some of the reactions are there which takes place in presence of heat only. Number 1, close contact is must for all, and number 2, solution form is must for all. Not for all, but must for all. Then close contact is for all. Then heat energy is for those reactions where we need to apply heat. And light energy, one of the condition is light energy, and this light energy is also for those reactions which take place in presence of light only. So some chemical reactions can take place only in the presence of light. They are called photochemical reactions. They are called photochemical reactions. So what are photochemical reactions? The chemical reactions which take place in presence of light are called photochemical reactions. So these photochemical reactions takes place in presence of light only. Okay, one of the very much common photochemical reaction is photosynthesis, as you know very much from your class 4 or 5 only, that what is photosynthesis. It is the process by which green plants prepare food using carbon dioxide and water. So this is photosynthesis, and this reaction takes place in presence of light only. If there is no light, photosynthesis doesn't take place. So what really happens in this photochemical reaction called photosynthesis? 6 molecules of carbon dioxide reacts with 6 molecules of water in presence of sunlight and chlorophyll, because chlorophyll helps in trapping sunlight which is present in green leaves. Then that converts into glucose, and 6 molecules of oxygen are also given out as byproduct. That's why photosynthesis is essential for all the living things, because this is only the way through which we get oxygen. That means through which balance of oxygen is maintained in atmosphere. Then another is electricity. So some chemical reactions occur only when electricity is passed through the reactant. Such reactions are called electrochemical reactions. So what are electrochemical reactions? The chemical reactions that take place in presence of electricity is called electrochemical reactions. For example, water decomposes into hydrogen and oxygen gases when electric current is passed through it. Water decomposes into hydrogen and oxygen gases when electric current is passed through it. So you can see here two molecules of water. When electricity is passed over it, it will give hydrogen gas and oxygen gas. That means water decomposes in presence of electricity to give hydrogen gas and oxygen gas. So that means by the decomposition of water also we can get oxygen gas as well as hydrogen gas, and we can keep these two gases into different cylinders. Then another is pressure. Some chemical reactions take place when the reactants are subjected to high pressure. So there are some reactions which does not take place with very much common conditions. They need pressure also. So the most common example in which pressure is required is formation of ammonia. That means manufacturing ammonia gas from nitrogen and hydrogen. We need pressure. A high pressure is required. So nitrogen gas reacts with 3 molecules of hydrogen gas at 450 degrees Celsius under 200 atmospheric pressure to give ammonia. And this arrow, which is directed towards both the side, one arrow is moving half, means partial, moving towards product side, and one is moving from product side to reactant side. This signifies that it is reversible reaction. That means just reversing the condition, you can get back the original substance. That means if you reverse the condition, ammonia breaks into nitrogen gas and hydrogen gas. Okay, so what are the conditions we learned today? 6 conditions, and these are: number 1 is close contact, number 2 is physical state, that means generally you need to convert the reactants into solution form. Number 3, heat energy. Some of the chemical reactions are there which takes place in presence of heat only. Then there is light energy. Some of the chemical reactions takes place in presence of light. And number 1, most common example is photosynthesis. Number 5 is electricity. Some of the chemical reactions that take place in presence of electricity only, and they are called electrochemical reactions. And then number 6 is pressure. Some of the chemical reactions are there which takes place under high pressure. So this much for today. Thank you.